we're going to find the integral that represents the area bounded by these curves that is marked with the green color. So for example, this one we want the integral that represents the area bounded by this curve only in this part, in this third quadrant. This is the area bounded by the curve, all this part. This is the area bounded by the curve in the second quadrant. Here is all the area bounded by the curve. Here is the area bounded by the curve in the third quadrant. Here is the area bounded by the curve inside that loop. And then this, the area bounded by all the curve. The area bounded by the curve in this first and second quadrant. The area bounded by the curve in the third quadrant. The area bounded by the curve in the first and second quadrant. Here the area bounded by the curve in the first, second, and third quadrant. And the last one, the area bounded by the curve in the third quadrant. So is this. Alright. Now the easiest way is to just look at the degrees and do it visually. And there are other ways in which you can do it a little bit visual, but with some arithmetic. First, let's do it in the visual way. Here we will have, remember that the area bounded by a polar curve is of the form 1/2 times the integral from alpha to beta of r of theta squared. This just means r squared, but r is a function of theta here. R is a function of theta, delta theta. Alright. So this one would be 1/2 of the integral from, let the limits of integration at the end, r squared, I will just indicate it, 1 minus 2 cosine theta squared delta theta. Here the bounds of integration are all this part. First, how we can do it. We know that we go from a x-intercept to another x-intercept. You could say we're going from the first intersect to the second x-intersect, or you could say we're going from the first intersect to the vertical first intersect, or we are going from the x-intercept to the r equals 0. Here, if you see r is equal to 0, that is, these axes are x and y. Here we have x and y. Remember that r is equal to the square root of x squared plus y squared. So whenever x and y are both 0, r is going to be 0. So at this point, we are bounded by the x-intercept and r equals to 0. So the bounds of integration will be alpha is when we're in the x-intercept. So how do we find the x-intercept? Remember that x is equal to r cosine theta and y is equal r sine theta. So we want the x-intercept, we use this one, is when y is equal to 0, is when 0 is equal to 1 minus 2 cosine theta times sine theta. When does this happen? Either this is 0 or this is 0. If sine theta is 0, the intersects of this curve, the x-intersects, are going to be when theta is equal to 0 pi, 0 pi, 2 pi, etc. So the x-intercept, if you see here, we are in some x-intercept, that is when theta is equal to 0. The other intercept is in x equals theta, theta equals pi, etc. The other is 0 equals 1 minus 2 cosine theta. Here you pass the minus 1, switch signs, and you have cosine theta is equal to 1/2. So theta is pi over 3, 60 degrees. Here, as you can see, in 60 degrees, we have a intersect at the x-axis. So here doesn't look very well, but at theta equals pi over 3, we have a x-intercept. This is because all this is a little bit moved. look, let's just for see how is the structure. Let's do what are the y's intersect. So when x is equal to 0, we would have 0 equals to 1 minus 2 cosine theta times cosine theta. Either theta is, well, cosine is equal to, cosine theta is equal to 0, in which case theta would be pi over 2, 2/3, pi, etc. Or 1 minus 2 cosine theta is equal to 0, in which case we have minus 1 equals minus negative 2 cosine theta, and so we have cosine theta again is equal to 1/2, so theta is equal to pi over 6. So at pi over 6, we have that x and y are both 0, so we have that is our r. R is equal to 0 when pi is equal to, sorry, pi over 3. The other way to do this is, you just set 0 equals to 1 minus 2 cosine theta, and you have exactly the same. Theta is equals to 1 pi over 3. So at pi over 3, we are in this 0. That's some x intersect, some y intersect, and r equals 0. And the other x-intercept is here. So this integration will be from here to here. So you can say that we go from 0 to pi over 3. That's our bound of integration. Let's see if we can do the other a little bit quicker and more visually. You can stop the video whenever you want. Here, visually is we're in the second and third quadrants. So the bounds of integration will go from pi over 2 to 3 halves pi, and our r would be theta squared cosine squared theta delta theta. That's it. And you can do other things like try to find the x-intercept and y-intercept, etc. Let's continue with this one. This would be 1/2 of integration. We're looking at the area that is bounded by the curve in the second quadrant. So we go from pi over 2 to pi of theta plus sine theta squared delta theta.